All right, for geometry today, we're doing 9-6, the surface area and volume of spheres. Um, I know that yesterday when we talked about that, you were like, what? But I promise you, it's not terrible. Okay, so our objectives are to define the terms related to spheres and then to apply the formulas for the surface area and volume of spheres. So I'm going to go ahead and move this up so we can look at our theorems here. All right, so the surface area of a sphere is the first one we have, is the product of 4 pi and the square of the radius. So we have surface area first, the S, and then the volume of the sphere is the product of 4/3 pi and the cube of the radius, or 4/3 pi times the radius cubed. All right, so we're going to dive in and start using these formulas in these word problems. Excuse me. Okay, so example 1 says the moon can be modeled as a sphere with a radius of 1,738 kilometers. Find approximations for the circumference and surface area of the moon. So we need to find C and we need to find S, our surface area. Okay, so first of all, okay, let's start with circumference. What's the formula for circumference? Good, it's 2 times pi times the radius. So we know that this is 2 pi, and our radius was up here is 1,738. So 2 times 1,738 is 3,476 pi. Or we're looking for an approximation, so our circumference is approximately 10,920.18 kilometers. Okay. Notice it's not kilometers squared or kilometers cubed because we're doing circumference, just the distance around. All right, so then let's look at our surface area. All right, let me change colors here maybe. So our surface area equals 4 times pi times the radius squared. So that's going to be 4 times pi. Our radius again was given to us, that 1,738. We're going to square that value. So that gives us 12,082,576 pi. So our surface area is approximately, if we multiply those out, 37,958,532, and it's surface area, so that's kilometers squared. Okay. So see, I told you today was not bad. It's not going to be bad. We're just plugging the numbers into the formulas, but it's a new formula. All right, so let's look at our next one. Okay, give us some room here. We want to find the volume of a sphere with a diameter of 10. Okay, well, if our diameter is 10, then our radius is what? Excellent, 5. And we're looking for volume this time. So we're going to use our volume formula. So V equals 4/3 pi times the radius cubed. Simple enough. The only thing we have is the radius. That's exactly what we need. Or like we could find the radius from the diameter, and that's what we need for our formula. So this equals 4/3 pi times 5 cubed, which is the same thing. It's equal to 4/3 pi times 125. 4 times 125 equals 500. So 500/3 pi. You could put that in and get out the approximation for our volume is 523.60 inches. It's cubed, so it's inches cubed, or it's volume, so it's inches cubed. after we've been doing the spheres and the pyramids and the cones and all the complex formulas, I hope you see like these formulas look complex, but they're actually really simple for you to plug in the values and to solve. Hopefully you're seeing that. All right, last one. Let's clear this and go to example 3. A lovely word problem. I know they're your favorite. So concerns have been raised about the use of giant plastic balls for aquatic recreation, as illustrated. If this ball has a circumference of 22 feet, find the ball's radius, okay, so we're looking for R, and the number of cubic feet of air it can hold. Okay, so cubic feet of air it can hold, that's our volume that we're looking for. Okay, so we know its circumference. Okay, but we don't know the radius, we don't know the volume. So let's use the circumference. What's the formula for circumference? 2 times pi times the radius. Okay, so we can plug our circumference in and solve for our radius. All right, so our circumference is 22, so that's going to equal 2 times pi times r. We can divide by 2 pi on both sides. So 22 divided by 2 is 11 divided by pi equals our radius. Okay, so we could keep this for like our intermediate answer to put into the other stuff, and we can go ahead and find the approximation. So the approximation for that is our radius is approximately 3.5 feet. Again, it's just feet because it's a linear measurement. Okay, so now that we know our radius, let's find volume. The formula for volume is 4/3 pi times the radius cubed. Okay, so this is going to be 4/3 pi. And I'm going to go ahead and put that exact number in, that 11 over pi cubed. Okay, because again, I don't want to necessarily use the approximate answer when I'm solving. I want to do the approximation at the very end. I want to save that till as late as I possibly can. So my answer is more precise. If you put the 3.5 in there now, you're going to get a varied answer. And it depends on the calculator that you're using too. So I'll take either one. Let's go with that. Because I know some of you don't have the fancier calculators. So this is going to be 4/3 times 3.5 cubed, if we want to do it that way. Or again, like you kind of put everything in your calculator and let it go. So 4/3 pi times 3.5 cubed should be equal to 42.875, which would give us 171.5 divided by 3 pi. And so our approximation for that is our volume is approximately 179.60 feet cubed. Whoop. Sorry, I kind of cut that off there for a second. So 179.6 feet cubed. And that's it for today for the surface area and volume of spheres. It really is just using and familiarizing yourself with those formulas. So you can get started on your homework, page 438. I'll see you tomorrow. Look at that, less than 10 minutes. Miraculous.